here's the formula for half-life. So A of t, we have a function of time. Half-life is time, so A of t is just like f of x, but now we have t. So a function of time is equal to a. Now this little sub-zero, a lot of people read it as naught, so a naught. So a sub-zero, which is our initial value, times 1/2, which makes sense, guys. Half-life, 1/2, raised to the t divided by h. So the t and the h are up in the exponent. It's t divided by h, where t is the time in, and h is what the half-life is equal to. So here's the formula. On the test, I'll give you the formula. I'll straight up say, here is the question, and then I'll say, use this formula. All you have to know is how to plug it in and do it correctly. Okay, so here we're going to do number 14 together. So, carbon 14 has a half-life of 5,253 years. Suppose you have a 12 milligram sample of carbon 14. It says, write a function that describes the amount remaining after t years. So we're dealing with half-life. Now once again, even on an end of level, a lot of times with things like this, they'll say, here is the formula. Here's the formula for half-life. They'll read you they'll give you the problem, and then you'll just have to know what to do. Now here's what throws people up with these kind of problems, is a lot of times there's a lot of numbers in the in the names of something. So carbon 14 is the name. The 14 has nothing to do with the amount of carbon. Carbon 14 is the name. Does everybody understand what I'm saying? Okay, so it says carbon 14 has a half-life of 5,253 years. So our half-life is equal to 5,253. And then it says, suppose you have a 12 milligram sample. So our initial amount is 12 milligrams. So now we're going to plug it into our formula. So we know that the formula is A of t is equal to a sub naught of 1/2 raised to the t divided by h. And we're just plugging it in. So this first one says, write a function that describes the amount remaining after t years. So we're leaving t as t. Plug it in. So we're going to have right here 12 milligrams. Does everybody see what I'm doing? 12 milligrams. And then our half-life is equal to 5,253 years. Now look, isn't that the only variable now is t? Yeah.
It says 5235.
5, 2, oh, okay, so 3, 5. So we'll do 3, 5. I did 3, 5 on my paper too. I just did it wrong up here. Okay, so it should be 3, 5, sorry. 3, 5. So 3, 5. Does everybody see how I plugged that in to my formula? So now it says, use the model above to predict the amount remaining in 1,000 years. So now 1,000 years has gone by. So we'll have 12 times 1/2 raised to the t is now 1,000. The time in is 1,000 divided by 5,235 years. Then you simply type it in your calculator. So once again, these are some of the easiest ones on the test. It would be such a shame to miss them, but you do have to know what you're doing. So 12 times 0.5. Now you should all practice typing it in, because half the battle is learning how to type it in correctly. 1,000 divided by 5,235. I'll type it in so you can know you got the right answer. 10.5 is what I got.
Wait, I got one more.
10.5. So you typed it in wrong. Make sure that what happens, usually what happens is when you raise it to the power. Right, it's raised to that power, yeah.
Jeez.
Okay, did you all get that? Okay, so now that's the only example you should need. Honestly, it's that straightforward for every problem. So now to finish problem number 14, because the amount remaining in 2,000 years. Basically, finish the worksheet, okay? So finish the worksheet so that we can move on to what we're doing today. Ready, set, go. Going to be lost. Okay, so today we're just going to spend some time. Actually, you should know how to do all this stuff, but let's be honest, some of you are not going to know how. So we're going to spend today going over how to solve quadratics that are in vertex form, because there's a easier way than what we had previously learned on how to solve a quadratic. If it's in vertex form, we'll learn a little trick. And then solving absolute value equations. We've got to remember how to do that, okay? So you guys, you will see absolute value equations on that end of level. All right, so remember that when dealing with quadratic, well, can somebody tell me what makes it quadratic? Why is it quadratic? Yeah. Good, it has a square, it has degree too, very good. Now remember that the first thing we do quadratic no matter what. Now notice this one is in standard form right here. Ax squared plus bx plus c, and it's equal to 0. So standard form, highest degree to lowest degree, and it's set equal to 0. Now we can solve quadratics in standard form by factoring, if it's factorable, or we can always use the quadratic formula. Now once again, if you can factor, I would do factoring, a lot less room for errors than the quadratic formula. But if you're really good at the quadratic formula, the nice thing is with the quadratic formula always works. Okay, so now now understand though, with quadratics, it's not always the best method to solve by factoring or solve by the quadratic formula. So we're going to get good at seeing different types of quadratics and how they're set up, and solve them in the easiest way for us. Why make it harder on ourselves? So everybody, when missing bx, we have seen this before. So everybody, ax squared plus c is equal to 0. Notice in this, I'm missing bx. Does everybody understand what I'm getting at here? I'm missing bx, okay? When you're missing bx, it is not the best way to get it set equal to 0, put it in standard form, and use the quadratic formula. It's not the best way to solve by trying to factor it either. There's an easier way. Simply isolate the square and then take the square root of both sides. So when missing bx, you can do this. So what am I going to do first? Isolate n squared. Add 33 to both sides, right? Are we all following me? 4n squared is equal to what? Negative 30, right? Okay, now we're going to do what? Good, I like that you said divide by 4 first. If we took the square root right there, it probably wouldn't be the best idea yet. Divide both sides by 4. So we have n squared is equal to this, is equal to negative 30 over 4. Now what will we do? Good, square root of both sides of the equation to undo the square. Now once again, recall the only reason we can do this is because we're missing the middle term, the bx. So we square root both sides of the equation, then our root cancels out their power. So right now we have n is equal to negative square root of 30 divided by 4. Now this is where a lot of you have struggled in the past, is simplifying this all the way down. We really will have to be able to simplify this completely down. So everybody recall, you can split this up. Can you? Oops, I did not mean to put that negative on the outside. Sorry about that. So we have the square root, like this, the square root of negative 30 over 4. Is everybody following me? You can't just pull out the negative. I just wasn't thinking when I did that. All right, so we can split this up. I'm going to rewrite this as the square root of negative 30 on top, and on bottom, the square root of 4, right? They're both under the square root, so writing it like this, they're still both under the square root, right? Yeah? Okay. So then we're going to go ahead and simplify it. So I'm going to go up to the side and simplify the square root of negative 30. So this is an aside. Ignore this for now. I'm going to simplify the square root of negative 30. Well, remember that what that technically is the square root of negative 1 times 30, right? Then 30 breaks down into what? 5 times 6. 6 breaks down into 3 times 2. And then looking at that, can you pull out any of those? There's not 2 of them, so you put them all back underneath, that's 30. But what can you pull out? Negative 1, and what comes on the outside? I. So the square root of negative 30 is I square roots of 30. Do you all understand that? So on top, we have I square roots of 30, and on bottom, we have what? The square root of 4 is 2. And then when we took the square root of both sides, we had to account for the plus and minus answer. So n is equal to plus and minus I square roots of 30 over 2. Okay, questions on that one? No questions. Okay. Alright, so what if we saw something like this? A lot of people, for some reason, still cannot quite figure this out. Everybody look at this. We have this is a quadratic, but look at it. Is it already factored? Yeah, it's already in its linear factors. So a lot of you see this and you start multiplying it back together, and then you refactor it and you end up back here. So don't go to the trouble of multiplying it together. The whole point of factoring is so that we can set linear factors equal to 0. Does everybody understand how these are linear factors? So we can just set each of those equal to 0. 2n minus 3 is equal to 0, and n plus 5 is equal to 0, and in each case solve for n. So we would add 3, 2n is equal to 3. Divide by 2. So n is equal to 3 halves. I like that answer much better than a decimal. In secondary 3, we don't really deal with decimals unless there's no choice. And then subtract 5. So n is equal to negative 5. Now once again, guys, we have two answers, which makes sense. It's quadratic. You all understand if we multiply this back together, it would be quadratic, right?
Yes.
So we always go with the highest degree. So there's our two answers. Now look back at our other problem. Was it degree 2? Yeah? Was there two answers? Yes. So you can always check to make sure. Okay, awesome. Do 1 through 6. Ready, set, go. So let's say we had an answer like this. This is considered not simplified. You would not see an answer like this on an ACT. You won't see it on my test either. You won't see it on an end level either. It's not simplified because we cannot have a root in the bottom of a fraction. So to fix that, we rationalize the denominator. So I'm going to multiply the bottom by that exact thing, the square root of 2. If I do that to the bottom, I must do that to the top. We're just multiplying by a fancy 1 right there. So we're not changing anything. So on top, we have 3i. Since these are both under a radical, we can multiply them together. Square root of 10, and then over. Now guys, for you advanced thinkers out there, think about how this works. Now watch. Isn't this the square root of 4? Yeah? Or, let's think of it like this. Isn't this the square root of 2 squared? Isn't 2 times 2 squared? Everybody? Yeah? So then look what happens. Our root cancels out with our power. What's on bottom? 2. Do you see how you would have got the same answer the square root of 4 is 2? But I want you to start thinking like that. Okay? Does that make sense? Okay, awesome. Alright, so now we're going to talk about what if the quadratic is in vertex form. So if it's in standard form, we're going to go ahead and use, okay, first of all, if it's in standard form, first thing we do is make sure it's set equal to 0, then we can solve by factoring or the quadratic formula. Well, if it's missing bx, we just do it like we just did. Well, if it's in vertex form, we don't want to have to multiply it all together, put it in standard form, which is what you had to do in the past. But now you're learning how to do it an easier way. So now guys, you all understand that vertex form is just graphing form, right? Okay, so if I say graphing form / vertex form, it's the same thing. Alright, so here we're going to do number 7. So we're given f of x is equal to negative 2 times x minus 2 squared minus 1. Alright, so the first thing we're going to do is set that equal to 0. So we're going to say negative 2 times x minus 2 squared minus 1 is equal to 0. Now, algebraically, piece by piece, we're just going to solve for x. Algebraically, in the correct order, okay? So what's my first step to get x alone? Good, plus 1 to both sides. So we're going to add 1 to both sides. So that leaves me with negative 2 times x minus 2 squared, which is equal to 1. Do we have questions up to here? Why is it not working? Just a second. Where the heck is the little thing? Okay, let's see if it's working now. Yeah, okay, weird. Alright, so then from there, how will we get x alone next step? Divide by what? Good. Divide both sides by negative 2. Very good. So then look, that cancels out, leaving us with x minus 2 squared, which is equal to, now that negative can just come out in front, negative 1/2. Is everybody okay with that? Everyone's comfortable. Okay, no questions. So then from there, what are we going to do? Very good. We'll take the square root of both sides of our equation. So then over here on the left, our root cancels out with our power, leaving us with x minus 2 is equal to the square root of negative 1/2. Can we simplify that? Yeah? Yes? Okay? So we'll split it up. We just did lots of problems like this, guys. We'll split it up, and I'm just going to do a little aside. I'm going to go off to the side and simplify this. So we have the square root of negative 1 divided by the square root of 2. Does everybody understand that? So then from there, I'm going to simplify it. The square root of negative 1 is I. Very good. Does everybody understand how we have an I on top? And then left underneath is the square root of 2. Well, is that simplified? No, we cannot have radicals in the denominator of a fraction, so I'm going to rationalize it. What am I going to multiply by? The square root of 2 to the bottom, and I must do the exact same thing to the top, so that it's just a fancy 1 that I've multiplied by. So on top, I have I square roots of 2, and on bottom, I have, everybody watch carefully, do I have the square root of 2 squared? Isn't 2 times 2, 2 squared? So on bottom, our root cancels out our power. So I have I square roots of 2 over 2. And then what did we forget to put in front of the square root? Good. So everybody, what we have right now is x minus 2 is equal to plus and minus I square roots of 2 over 2. Are we all okay? So then from there, I'm going to get x alone. What am I going to do? Add 2 to both sides of the equation. So then we have x is equal to. Now I'm going to push you to write it correctly. You'll write it in the form of the quadratic formula. So if you think about it, the quadratic formula is x equals negative b plus or minus the square root of that stuff all over whatever. Okay, so what comes first, the number or the square root? The number. So I'm going to put, is it positive 2?
Yes.
So I'm going to have 2 plus and minus I square roots of 2, but that's not all over 2, it's just this piece over 2. Do you see how I rewrote it? There's our answer. How many of you thought that was easier than the quadratic formula? How many of you would have rather just multiplied it all out and then done the quadratic formula? Okay, interesting. So it's just a matter of preference. So there's a lot less room for error right here though, so I'm going to push you to do it like this, okay? But yeah, I mean, it's a matter of preference. Whatever way fits you best, that's fine. As long as you get the correct answer. Do we need another example? No? So you want to do 7 through 12. Why don't you give it a try? 7 through 12. Ready, set, go. Here we go. Watching this carefully. So first things first, we set it equal to 0. So we have negative x minus 2 squared minus 4 is equal to 0. Right?
Yep. Right.
So then from there, we'll do what? Nope. Add 4 to both sides. So we have negative x minus 2 squared equal to 4. Then we will do what? Dylan, you should be watching this because you're smart enough to do it this way. So I'm showing you. Okay. So then what will we do? Very good. The first thing we would do before we square root it, that would be bad to square root it right here. We've got to we've got to isolate that x minus 2 squared completely. So we'll divide both sides by negative 1. So we have x minus 2 squared is equal to negative 4, right? So then what will we do? Square root both sides of the equation. Root cancels out the power. X minus 2 is equal to plus and minus what? 2 and a I. Then our last step is to add 2 to both sides of the equation. Can you add 2 with 2 i's? No. So we have 2 plus and minus 2i. Ding, ding, ding.
That's a lot easier.
It's a lot easier than most of you are making it. You didn't listen. Okay, so steps to solving an absolute value function. First things first, you isolate the absolute value expression. So it's very similar to solving all of our other equations. You have to isolate, just like we had to isolate what was squared, we have to isolate the radical. We're isolating the absolute value expression. Second, you'll set it equal to the plus and minus value of the other side of the equation. Because with absolute values, guys, it's just talking distance. Absolute values means what's the distance, and on the real number line here, if you're going positive 13, that's just distance 13. So you've got to do the positive 13 and the negative 13. Anyways, that's why that works. And then third, algebraically, piece by piece, solve for the variable. And then fourth, you'll check your answers. You really do need to check for extraneous solutions. Did everybody get that? Did you take a picture of it if you needed it? Are we all okay? Okay. Here's my first example. I'm not doing any from the worksheet because these are so easy that you can practice. You need to practice them on your own. Okay, so everybody look at my example. 2 times the absolute value of p minus 2 is equal to 10. Our first step was to isolate the absolute value. What should I do? Divide both sides by 2. Divide both sides by 2. So we have the absolute value of p minus 2 is equal to 5. Now once again, absolute value just means distance. So it says when is p minus 2? What is the distance to 5? So we have to do both positive 5 and negative 5. So just like a just like a quadratic, we're going to split this up. So we have p minus 5 is equal to positive 5, but p minus 2, sorry. P minus 2 is equal to positive 5, but also p minus 2 is equal to negative 5. Does everybody understand distance on a number line? Positive 5 and negative 5. So I did the plus and minus of that because we're talking distance. So then from there we'll solve for p. Add 2, so p is equal to 7. There's one of our answers. Add 2, p is equal to negative 3. Does everybody understand? Right, so we have 2 answers. We plug it back in and check it. So if we plug in 7, we'll have 7 minus 2, which is 5. The absolute value of 5 means the positive value of 5, which is 5. So 5 times 2 is 10. Now everybody pay close attention to right here. Negative 3, if I'm plugging in negative 3 minus 2, I get negative what? You guys listen, are you listening to what I'm doing here? Plugging in a negative 3 to check my answers. Negative 3 minus 2 is what? Negative 5. So let's see if this is a true statement. Well guys, the absolute value changes it to positive. It's just distance. So this is the same thing as 2 times 5. So is that a true statement? Yes. So we checked both answers. Are we all okay with that? Okay. So last one, and then I'll just let you finish this up. The absolute value of negative 6x minus 5 minus 3. First thing we have to do is isolate the absolute value. Add 3 to both sides. So we have the absolute value of negative 6x minus 5 is equal to 13. Then we have to set it equal to the positive and the negative of that. So negative 6x minus 5 is equal to positive 13. Negative 6x minus 5 is equal to negative 13. And then we're going to solve for x piece by piece. So we would add 5. So we'll have negative 6x is equal to 13, 14, 15, 16, 17, 18. Divide both sides by negative 6. We would rather have fractions than decimals. So 18 divided by negative 6. Negative 3. And then we would add 5. So we have negative 6x is equal to 13, 12, 11, 10, 9, 8. So negative 8. Divide both sides by negative 6. So x is equal to 4, positive 4/3. You didn't know how to do that, you just use your calculator, math, enter. What is your problem? Like, what's your question, I mean? What's your question? Where is it?
I get the A.
Because negative 13 plus 5 is negative 8.
Shut up, retard. Anyway, what's the other one?
And then
on the other side,
positive 13, so 13 plus 5 is 18.
So we subtract one side and the other.
Yeah, we're just solving for x in each case. Does that make sense?
Yeah, that makes sense.
No, those were good questions, everybody. Be nice, because guess what? Sometimes you're going to have questions and everyone thinks you're stupid too.
Yeah, Jaden.
But I all think you're smart, so that's all that matters. Ready, set, go. Finish the worksheet. So do 13 through 20 and don't put anything away until you check your...